Hi dear, today we'll see about the hydrocarbons. Okay, before that we'll see some of the facts about the organic compounds. Okay, so we'll call this compounds of carbon as organic compounds usually, right? So many compounds have been formed, and it is found that these compounds were initially extracted from the natural substance. Okay, these organic compounds are extracted from the natural substance and thought that it was only be formed within the living system, and thought that it will be formed only within the living system. You know that usually the plants make use of the inorganic compounds and then it converted into a carbon compound, right? That is, make use of the carbon dioxide and water and sunlight to produce glucose. That is a organic compound, right? So it is produced within the living system. Okay, it is they thought like that. Okay, and it was postulated that that means it had assumed that a vital force was necessary for this synthesis. For this production of this organic compounds, a force is required, and only it is produced within the living system, and or we can extract from the natural substance. Okay, and this postulate was disapproved by a Friedrich Hohler in 1828 by preparing urea from ammonium cyanide. Okay, so from ammonia cyanide is an inorganic compound. Okay, it is not carbon based. Okay, it is a ammonia cyanide. So from ammonia cyanide they prepare the urea. You learned in the biology that urea is produced in the liver. That means in the protein synthesis, while breakdown of protein, protein will be converted into simpler form in the form of ammonia acid, right? Sorry, amino acid, right? So that excess amino acid will be converted into urea, that is produced in the liver, right? So that urea will be discharged with the urine, right? So in the living system only these are all produced, but he proved that he has prepared the urea from the ammonia cyanide, that is from the inorganic compound. Okay, from that he disapproved this above postulate, that is it requires only the living system for the production of organic compounds. Okay, but still till now we are studying all the carbon compounds under the organic chemistry only. We are consider everything under the organic chemistry only, except carbides, oxides of carbon, carbonate and hydrogen carbonates also studied under the inorganic chemistry. Okay, coming to the hydrocarbons. What is mean by hydrocarbons? Name itself it states that the organic compounds which are made up of carbon and hydrogen, that is called hydrocarbon. Carbon only made up of carbon and hydrogen atoms, it is called hydrocarbons. Example, methane, ethane, okay, CH4, okay, C2H6, like that. Okay, it is made up of only carbon and hydrogen atoms. Okay, this is called hydrocarbons. So there are two types of hydrocarbons. We call it as saturated hydrocarbons and unsaturated hydrocarbon. Two types are saturated and unsaturated. While studying the versatile nature of the carbon itself, we have studied the saturated hydrocarbons, unsaturated. That means if the single bond is formed between the carbon and carbon, we'll call it as saturated hydrocarbons. The hydrocarbons having single bond between carbon and carbon atoms, we'll call it as saturated hydrocarbons. Okay. And for the single bond between the carbon, we will group under the alkanes. Okay, usually they'll have the same functional group, and prefix and suffix will be in a pattern. Okay, so if there is a single bond between the carbon and carbon, we will call it ane families, alkane, ane family. Okay, CH4, that we will call methane. Okay, methane. Okay. Then unsaturated means the hydrocarbons having double bond. The double bond means we'll call it as alkenes, ENE family, and triple bond means YNE, alkynes, YNE family. Okay, between carbon and carbon atom are called unsaturated hydrocarbons. Okay, for example, ethane, ethyne. Okay, we'll draw all this thing. Okay, first we'll. Saturated means only single bond between the carbon and carbon. Unsaturated means it may be either a double bond or triple bond. Double bond family we call it as alkenes, and triple bond family alkynes. Okay. So how do you remember this? How many carbon atom will combine with the hydrogen atom, like that? You will have a confusion, right? We have a standard formula for that. Okay, alkane means single bond. Its formula is CnH2n plus 2. So if you put here, the n represents the number of carbons. Okay, if you put number of carbon n equals to 1 means then it becomes C 2 ones are 2 plus 2 4, so CH4. So this is methane. Okay, likewise for alkenes, alkene means double bond, right? So the general formula is CnH2n. Okay, here for alkene and alkyne family, this we will not substitute one carbon, because we will start from the 2 carbons only. Okay, 2. Okay, alkyne, it is triple bond. For general formula is CnH2n minus 2. Okay, so you can easily remember this formula. The general formula is CnH2n. Okay, if it is alkane, you have to add plus 2. If it is alkyne, it is minus 2. Okay, and alkene, it is general, simply CnH2n. Okay, so you can easily make the, based on the number of carbon, how many hydrogen atom will be attached to that. We can easily find that. Next, we'll see how to arrive at the structure of these organic compounds. Okay, so first we have to connect the carbon with the single bond. Okay, first we have to connect carbon to carbon with the using the single bond. Then we have to check whether the valency of the carbon is satisfied or not. Okay, then we have to connect based on the number of hydrogen. Okay, so here only one carbon is there, so we will write this carbon. So what is the valency of the carbon? 4, right? Okay, then how many hydrogens are there? 4 hydrogens. So we can easily connect with the carbon. Now the valency of carbon is satisfied. That's all. Okay, so since it is a combined, it is a single bond between the carbon and hydrogen, we'll call it as a saturated hydrocarbon, right? Okay, fine. Next we'll take this butane. Butane, here 4 carbons are there, hydrogen is 10. Okay, so we can first connect the carbon using the single bond. Okay, so carbon has been connected. We need to satisfy the valencies for the carbon, right? So for this carbon, already 1 is satisfied, remaining 1 2 3 4. Okay, now it is satisfied, right? Here 1 2, so remaining 1 2 1 2 1 2, so 4 satisfied. Here only 1 2 3 4. Okay, so totally 10 hydrogen. 1 2 3 4 5 6 7 8 9 10. Okay, so now it is satisfied. Okay, so this is in the straight line. Okay, we can make the compound can be of a long chain or branched also we can put. So how can you connect this by branch? First connect the carbon to carbon like this, and we can connect one more carbon like this. Here one more carbon. Okay, here the valency of the carbon should be like this. Here 1 2 3 bonds are there, one more we can draw like this, and here 1 is there, 2 3 4. Here 1 is there, 1 2 3 4. So how many hydrogens? 1 2 3 4 5 6 7 8 9 10. So it is satisfied. Okay, so all are single bond. So since all these are single bond, it is a saturated hydrocarbon. Okay, so it is of a long straight line structure, and this is a branched structure. Okay, next we will go for the hexane. Hexane means we know it is 6 carbons only. Okay, if it is a straight line structure, then to satisfy the valency it needs 14 hydrogen. Okay, if suppose this carbons are arranged in a ring manner, We know that it can be formed in any manner, straight line, a long chain, or branched, or ring manner also we can form. Okay, when these carbons are connected in a ring manner, then it needs only 12 hydrogen to satisfy its valence. Okay, let's see how it is. Okay, first we'll draw the straight line form. Okay, how many carbons? 6 carbons, right? One, first it has to be, carbon has to be connected, the single one. 1 2 3 4 5 6 carbons. Okay, to satisfy this we need 3 hydrogen here, here 2, here 2, here 2, here 2, here 3. Okay, so totally 1 2 3 4 5 6, here 12 13 14 hydrogen is there. Okay, so this is your hexane. This is the structure of hexane. Okay, if suppose if it is connected in a cyclic manner, okay, all the 6 carbons are connected in this manner, ring manner, means hexane means 6 sides, right? It will be connected like 6. Okay, here 1 carbon, 2 3 4 5 6. Okay, so here 2 valences are satisfied, so it need 2 more valences. Here 1 2, this is 1 H. Likewise for this also 1 1. So for each carbon 2 will be connected, hence the cyclohexane formula becomes C6H12. Because if it is connected in a cyclic manner, ring manner, then 12 hydrogen is enough to satisfy its valency. Okay, but when it is connected in a straight line, it needs 2 more hydrogen atoms to satisfy the valency of carbon. Okay, so this is the cyclohexane. Okay, next, okay, we need to check if it is connected. Okay, here in this cyclohexane we have drawn the in a ring manner, right? So in the ring manner, if it is connected, it forms a saturated hydrocarbon, because all these are saturated hydrocarbon, because all these are single bond. Okay, if it is drawn in a branched manner or straight line, straight line, what is that bond form instead? Okay, cyclohexane formula is C6H12. Okay, so if it is connected in a straight line, C6, 1 2 3 4 5 6. Okay, 6 carbon, 12 hydrogen means 1 2 3 4. Okay, 12 means here 6 hydrogen, here also 6 hydrogen. Okay, if you check this valency of this carbon, it is satisfied 1 2 3 4. Okay, here this is also satisfied 1 2 3 4. Here this is also satisfied 1 2 3 4. Here this is also satisfied 1 2 3 4. But if you check this N carbon, here only 3 valencies are satisfied, right? One more, if you connect one more hydrogen atom, it becomes H13 and 14. Okay, right? So, but we are having only 12 hydrogen. So what we have to satisfy this valency of carbon, here it will form a double bond between this carbon. Okay, likewise for this end, here also it has to satisfy the one more valency, right? So it forms a double bond between the carbon. Okay, now this way, because of this structure, it become a unsaturated hydrocarbon. Unsaturated hydrocarbon. Okay, clear on this? Even if you form a branched one, for example 1 2 3 4 5, suppose you are connected like this, some branch like this. Okay, here you are going to connect like this. Here it is satisfied, here it is satisfied, here also it is satisfied, Here also it is satisfied. Okay, now we have to satisfy this. Already how many hydrogen we have filled? We need to fill 12 hydrogen, right? 1 2 3 4 5 6 7 8 9. So 3 more we have to fill, right? So for this already it is connected. For this 1 2 1 hydrogen carbon we can connect here. 1 2 3 is satisfied. So to satisfy this we can form a double bond here. So 1 2 3 4. Here this carbon is also satisfied. So how many hydrogens are left out? 4 8 9 10 11 12. 2 more is there. For this carbon we only 2 are satisfied. 2 more valency is there. So we can connect hydrogen like this. Okay. If it is branched or in a straight long chain manner, then this cyclic hexagon become a unsaturated hydrocarbon. Okay, unsaturated hydrocarbon. When it is connected in a ring manner, it forms a saturated hydrocarbon because all the bonds are single bond. Okay. Here, when it is connected in a straight line or in a branched manner, it forms a double bond. Double bond. If double bonds are present in this carbon and hydrogen atom, then it is called unsaturated hydrocarbons, right? Next, we'll see the structure of benzene. Benzene, it is C6H6. Okay. Against hexagon, we can draw ring-like structure. Carbon, 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 carbon. Okay. So already we have filled 6 carbons. So 6 hydrogen are there. So we can connect to each carbon atom. Okay. So we have connected the hydrogen to each carbon atom. But if you check the valency of the carbon, it is not satisfied. See here 1, 2, 3. Only 3 valencies are satisfied. So to make the valency satisfied, we are going to put the double bond here. Okay, now it is satisfied. 1, 2, 3, 4. Okay. Okay, next. Now look at this carbon. Is it satisfied? 1, 2, 3, 4. Now it is satisfied. Okay. Next. Coming to this. Here 1, 2, 3 is there. If you put double bond here, then this become more than 1. Okay. More than 4, right? So we should not put the double bond here. So we can put the double bond here. Now it is satisfied. 1, 2, 3, 4. Okay. Likewise here it is satisfied. 1, 2, 3, 4. Okay. Next, coming to this, you should not put double bond here. Then it become extra 1 electron will be there. Okay. So we have to put double bond here. Now it is satisfied. 1, 2, 3, 4. Here 1, 2, 3, 4. Everything is satisfied. This is the structure of benzene. Okay. So if it is a double bond or triple bond, then we will call it as unsaturated hydrocarbon. If it is a single bond, then we will call it as saturated hydrocarbon. Okay. Thank you.